Welcome to Tech Jotters. TensorFlow is one of the major player in AI world, and it is really complicated to install and configure properly. So in this video, I'm going to show you the proper way to install TensorFlow on WSL Ubuntu. Okay? If we go to the TensorFlow website, and on the install tab, if I go to the PIP, you can see if you select Windows native, only the TensorFlow 2.10 was the last TensorFlow that supported GPU on native Windows. So to use the latest TensorFlow, we need to install it on WSL. Okay, so I choose WSL for that, and the latest Ubuntu 24.04 is available on the WSL, so you can use it, but the same process will work with Ubuntu 22.04 as well. So if you want, you can use Ubuntu 22.04, but in this case, I'm using Ubuntu 24.04. I made a previous video about the TensorFlow, but some users have problem with that, so I'm making this. This is the updated version of that video. So let's get started. In this video, I'm going to show you the total process and why I'm using the specific version. Okay, so let's open this one. So the link is provided on the description. You can see the TensorFlow 2.16.1, which is the latest one right now, is supported CUDA 12.3 and cuDNN 8.9. That's fine. So we can install 12.3 and cuDNN 8.9. But when I installed it, I tested it. It shows that everything is working fine, but it shows some warning about TensorRT because it is not finding the TensorRT. Okay, so the problem is I installed the latest TensorRT, the version 10, and the version 10 TensorRT is supported CUDA 12.3 and cuDNN 8.9. That's fine, but TensorFlow can't recognize that TensorRT. Okay, so I searched a lot and find a thread, and here I can see the 2.16.1 latest version is supported by 8.6.1. So that's a big problem. So when I went to the TensorRT 8.6.1, there is 8.6 version, and here I found the TensorRT 8.6 for Windows 10 and CUDA 12 and 12.1. So it doesn't support CUDA 12.3. So what I am doing here, to use everything, I will install CUDA 12.1 and the related cuDNN file and the TensorRT 8.6. And I tested it. It works perfectly. And I will run all the commands in front of you. And I will also copy and paste all the commands to the description so that you can easily follow this. And there is another thing, if you want to use the latest CUDA 12.3, because you can see the TensorFlow 2.16.1 is supported 12.3, you can install it, CUDA 12.3 and 8.9, but you don't need to install TensorRT because TensorRT will not work. So if you okay with that, like if you don't use TensorRT, then you can avoid TensorRT and install CUDA 12.3 and 8.9, and you can follow the same way I'm showing you. So that's fine. Just avoid the TensorRT, and you can install TensorRT, no problem, but TensorFlow will not get that. Okay, so let's get started with TensorFlow installation. So I'm going to use my terminal. Here is my terminal. Okay, so here I can start WSL in two ways. I can write command here, or I can click here and select Ubuntu 24.04 it's installed. So if I click here, I can start Ubuntu 24.04. So I will start from here, and the command will be WSL, and I want to start in the home directory. So I will put this one and press enter, and it will start Ubuntu 24.04, and you can see the Linux is started. So, and I'm in the home directory. Okay, so the next and first thing is update the repository. Okay, so the command is sudo apt update. Run this, and you need the password, sudo administrative password for the sudo. So it's already updated, and you can see the 58 packages can be upgraded. So we will run sudo apt upgrade to upgrade those packages, and we need to say yes, we want to upgrade everything. This is the basic thing. Whenever you want to use Linux, this is the best way to update the repositories and upgrade everything before starting any kind of change. Okay, now our Ubuntu is upgraded. It's the latest one right now. So what we need to do next is to install the prerequisites for CUDA toolkit. Okay, so to do that, I will run this command sudo apt install build essential. So build essential is a bunch of packages that need to create, make files and everything. So it will install everything for us, including GCC. We need GCC to install CUDA. Okay, so let's install this, and we need to press yes. Okay, so the build essential is installed, and our WSL Ubuntu is ready for the next thing. Okay, so now I need Python. So if I click Python here, you can see Python is not installed. So I need to install Python. So you can install any Python. You can install a sudo apt and Python, and it will install the latest Python. But I want to install the Miniconda Python. Okay, so let's go there and search for Miniconda. So why I like Miniconda? Because after installing Miniconda, I can change the Python version when I make the environment. So for the TensorFlow, we will use Python 3.10 version. Please remember this. But we will install the latest Linux for our system. And if you click here, Linux installer and download pkg installer, you will get the links for Windows, Mac OS, Linux. I will go with this. So let's copy this link, and we'll run this command wget. So with this, we will download the latest Miniconda. Okay, so our Miniconda is downloaded. Now we need to install it. So the command is bash and /Miniconda latest, the file name. So we need to press enter. As it is the usual one, how you install Miniconda, it's the simplest thing. I will install in the default directory. And yes. So our Miniconda is installed. So what we need to do is reopen our current shell. So I will close it, and I will open the terminal again. Now again, if I start WSL, you can see the base. That means the Miniconda is installed perfectly. You can check with Python command, and you can see the Python 3.1 2.3 is installed. Okay, that's fine. Let's exit it. Sorry. Okay, we are now out of Python. The next thing is we need to download CUDA. So as I told you, I will install CUDA 12.1. So let's go to the CUDA toolkit and search it. We need to go to the CUDA toolkit archive, because The latest one is 12.5. If you click on the CUDA toolkit, it will take you to the 12.5.0, okay? But we need the 12.1. So let's click here, 12.1.1. I will go with the latest one, okay? You can also download 12.1.0. This is not a problem, so I will go with the 12.1.1. So let's click it. Let's click Linux and x86 64, and we want to install it Ubuntu, WSL Ubuntu. So click here too, and we will download this with the local file. Sorry, we will run file, the local run file, okay? So what it will do, we need to download this with wget command. So let's run it. It will be a big download, so I will fast forward it. So our CUDA toolkit is installed. So before installing CUDA toolkit, we will check our GPU version. So the command is NVIDIA SMI. Okay, and you can see the NVIDIA SMI is showing the driver version 555.52.01. So this is the NVIDIA SMI graphics card GPU version. So I don't install it on WSL Ubuntu. It is coming from my host Windows. Okay, so make sure you install the proper graphics card for your GPU on the Windows. You don't need to do anything on Ubuntu because Windows will pass through the graphics card driver to the WSL Ubuntu or WSL Linux. Okay, so this is the thing. So our GPU is working here. The next thing is we need to run this command. And if I run this, it will start installing the Linux, CUDA for Linux. And we need to give our password again. Now here is another thing. If you don't install the build essential, you will get error. Okay, so please make sure you install the build essential first before running this command. It takes a long time, and after a long time it shows me the end user license agreement. We need to type accept to accept the license, and here you can see the CUDA toolkit 12.1, CUDA demo suite, CUDA documentation, everything is selected. I don't need the kernel objects, so I will directly go to the install and press enter. Now it will start installing CUDA 12.1.1. So now our CUDA 12.1 is installed. So it's also says we need to put these into the path. So let's start it. So to put them into the path, I need to go to the bashrc. So I will open bashrc with nano. And here we need to go to the end of the file, and we need to put these two lines here, and you can actually go to the description to get this path. And one thing, if you decide not to use TensorRT and go with the latest supported CUDA version, that is 12.3, you can download CUDA 12.3 and install in a same way, but here you need to put CUDA 12.3. okay, just change 12.1 to 12.3, and here also then it'll work. And if you want to copy this path, install it in the default directory, you can use the same path direction, so you can copy it from the description and paste it here. Okay, now I will press Ctrl O to write on the file and enter, and Ctrl X to close it. Okay, the next thing is we need to source the bashrc so that it will take effect. Okay, now I need to go to this file sudo nano /etc/ld.so.conf, this file, and also you will get it in the description. Enter here, and you need to copy this link, this directory path here. Okay, so it is user local CUDA 12.1 and leave 64, and you need to press again Ctrl O to write the file and Ctrl X to close it. Okay, now we'll run the ldconfig command, and if it doesn't show anything, that means it's working fine. If it show anything after running this, then we need to figure it out. So it doesn't show anything, so everything is working fine. Now we'll check our path with the command echo path, whatever we actually put into the bashrc file. So here you can see the user local CUDA 12.1 bin file is here. So that's working perfectly. And the second one is we need to check, sorry, not this one. We need to check the LD library path. Okay, and here you can see the user local CUDA 12.1 and lib64 is here. So this is actually from this file. Okay, so it's showing that everything is working perfectly. Our path is fine. So let's check CUDA from the ldconfig. Let's run it. Okay, it will actually find CUDA from the ldconfig, and you can see CUDA 12.1 is here. Okay, under the user local CUDA 12.1. That's fine. Now we need to check the CUDA version. That command is nvcc ---- version. It should show you the CUDA version you are using. So here the build is 12.1. That's fine. Release is 12.1. So our CUDA toolkit is installed perfectly. The next thing is we need to now install cuDNN. Okay, to do that we need to go to the cuDNN archive. So let's go to the cuDNN archive, and here you can see the latest one is 8.9.7, and it's for CUDA 12x. So it'll support all the 12 version, okay, from 12.1, 2, 3, 4, 5, everything. So that's good for us. We will download this version. So we'll go and download the tar version. Okay, so here is the tar file. We'll go and download this one, and now it is downloading in my computer because I already logged into the developer account. If you don't have one, you need to create a NVIDIA developer account, and it's free. So if you install it and log in, you can download it. Okay, please remember this. If you find any login page, just if you have any login ID, just log in there and you can download it. And if you don't have, you need to create one. So the cuDNN file is downloading. It's a big file. Now another problem is I tried to download this file directly to the WSL with the wget, but because you need to log in here, it's not working. And I also paste the put the link to the description, but if you click there, you will go to the main page. So please come here. You need to navigate here to download this file. Okay, so it is still downloading. Now it's completed. So let's go to the download folder, and here is the cuDNN. Okay, so now I will copy this one and take it to the Linux, WSL Linux. So if you go here, you can see the Linux. If you're using WSL, you will get this Linux option. Click here and you will see the version Ubuntu 24.04. Go there and home, and my name is TechJotters. So here is the home directory. We will paste it here. Okay, so if I open the terminal and press WLS, it should show me the cuDNN file. Okay, so it's here. That's perfect. Now we need to extract this one. So the command is tar minus xvf and the file name. So if you press enter, it will start extracting all the files. Okay, so the files are extracted. So let's go inside this folder, that is this file. Inside this folder, we need to copy some files, the include and cuDNN age star.h. That means any file named with cuDNN, starting with cuDNN, and the ending is .h, will be copied to this directory. Okay, so let's press enter, and again the command is pasted to the description. So what happened here, I'm just copying and paste all the commands here because before making this video I tried it multiple times so that I can get the proper way to install everything, and in that time I copied all the working commands. So I'm running this. I'm not typing it because it will take a lot of time. So, and the same commands I will put to the description so that you can just copy and paste them. If you use the default directories, it should work perfectly. Okay, just you need to download those files because they need the login. That's why I couldn't put the link there, the direct download link. I put the link for this cuDNN archive and TensorRT, and inside that you need to download them. Okay, let's go out from this directory. Now let's check everything. Okay, inside this directory we have all the files. So you can see the libcuDNN, OPS, infer, and everything is here. So that's great. Everything is copied to this directory. That's fine. So let's now test the cuDNN if it's working or not. Okay, so we'll create a C file. Okay, C programming file with the command nano test underscore cuDNN.c. So it will create a C file and we'll paste all the codes here, and of course I will put these codes so to the description so that you can copy and paste. And I'm not sure if I can paste all these commands to the YouTube description. If it's not possible, then I will put it to the Git repository and share the Git link so that you can copy and paste everything. Okay, so Control X. Now we need to run this. First we need to compile it with GCC, and then if I run this with // and test cuDNN, you can see the cuDNN successfully initialized. So our cuDNN is also completed. CUDA toolkit is done, cuDNN is done, now the TensorRT. So here again, if you decide to go with the latest CUDA 12.3 supported by TensorFlow 2.16.1, and if you want to go with that, you don't need to install TensorRT because TensorRT will not support that. But if you want TensorRT, just follow exactly this, and you need to also install TensorRT. So let's go to the TensorRT. The same process as CUDA cuDNN. Okay, so let's click here, get started, and if you click download, it'll take to the available versions. So we will go with the TensorRT 8. Okay, because that's supported, so we need to agree. And here you can see the TensorRT 8.6 GA. EA means early edition, GA is the stable one. So if you click here, you can go there and you can see that 8.6 is only supported by CUDA 12.0 and 12.1. So we need this zip file. So let's click it. And again, if you don't have the developer account login, then it'll ask you to log in there. I already logged in there, so it's not asking me any question. So the TensorRT is almost downloaded. Okay, so let's go to the download folder and copy TensorRT, and again go to the Linux, Ubuntu 24.04, home, take jotters, and you need to paste it here. This is the home directory. And now if I go to the terminal and find ls, you can see the TensorRT is here. So it's a zip file. We need to unzip this. Okay, sorry, I made a mistake here. I'm extremely sorry for that. I downloaded the Windows version. We need to download the Ubuntu version here. You can see the Ubuntu versions here actually. Ubuntu 20, this is Ubuntu 20.04. And here you can see the Linux 8664 CUDA 12 tar package. We need to download this one. I'm extremely sorry for that. So I will go to the Linux directory and remove this zip file. Okay, so it's downloaded. Let's open this and copy this file, not the Windows one. Okay, and let's paste it to the home directory. And if I go to the terminal and press ls, you can see the TensorRT tar.zz is here. So that's fine. Now we need to actually extract this file. So the command will be tar -xvf, and we need TensorRT, this file. We'll extract this. So press enter. Okay, if I press ls, you can see the TensorRT 8.6.1.6 file is generated. So we'll move this. This is in the home directory. So we'll move this to the user/local directory. So the command will be sudo move TensorRT 8.6.16 _ like this. Okay, so let's press enter. So everything is moved. If you press ls, you will not find the TensorRT directory here, but if you just ls this location, you will see the directory. You can see the TensorRT is here. Okay, so now again we need to put this directory to the path so that TensorRT can be found from anywhere. So again we need to open bashrc. The command is nano, then the I don't know the name of this, the home directory sign, then /bashrc, then you will open this bashrc file, just like previous what we did for the CUDA. Okay, here we need to add 2 more lines for the TensorRT. And again, if you install everything and follow exactly what I am doing here, you can just copy and paste these 2 lines, and it should work. Okay, so this is the 2 lines we need to add. Then Control O and Control X, and we need to source the bashrc file so that the effect will take place. Okay, so now again, if you want to test the path, you can run the echo path, and you will see the TensorRT is here. See, so that's great. It's working. And here for this echo ld_library_path, you can see the TensorRT file is here. The path is here. So both are in the path and working perfectly. So that's fine. Our TensorRT is, I think, working perfectly. Okay. Now, so we installed CUDA 12.1, cuDNN 8.9, and TensorRT 8.6. everything is installed and the path is configured, so it's time to install TensorFlow. Okay, so let's install TensorFlow first. Before installing TensorFlow, I will create a environment for my TensorFlow. Okay, because I want to use Python 3.9 for TensorFlow, or you can also use Python 3.10, but I will go with the 3.9 version. Okay, so I'm creating the Conda environment named TF and with Python 3.90, because if you remember, when I write the Python command, it shows the Python version is 3.12, and if you use 3.12, TensorFlow will not work. So we will use the previous version of Python. So we need to create a environment. So let's create the environment with the name TF. So it's super simple. We need to just activate the TF. So it's activated. The next thing is I will make a directory here with the name ML, and I will put everything inside this ML folder. It's so that I can organize them. Okay, this is not mandatory, but if you want, you can follow this way. Okay, here is this. Now we need to install TensorFlow. So let's go to the TensorFlow, and if I click PIP, and here is all the options. If I click Windows WSL2, you can find the command to install TensorFlow. So let's copy this one and run it to the terminal in the TF environment. So let's run it, and it will download and install everything for our GPU. Okay, so TensorFlow is installed. So let's go to this installation instruction page and copy this. If we can see the device is GPU, then it works perfectly. So let's run this command. And you can see the device type is GPU, and we didn't get any warning for TensorRT. So again, if you follow these steps and you want to run the CUDA 12.3, and if you don't care about TensorRT, you can run this following exactly these commands. Just change the version names, then it will work, but you will get a warning here for the TensorRT. But here I didn't get any kind of warning for TensorRT, so everything is working perfectly. For this NUMA node warnings, these are not error, these are warnings. So I tried to fix them, but what happened here, these are some kind of BIOS thing, and in my motherboard I don't have the option for NUMA nodes. So I tried to contact with them, and they said in my motherboard it's not available, so I can't do anything for this. So and I search everything. This warning will not hamper your performance or anything. So that's fine. It's actually not important. But the most important thing is this line. You can see the physical device is 0 and device type is GPU. So our GPU is working. Okay. So now TensorFlow is installed. We'll install JupyterLab. Okay. Because most of us will use JupyterLab for this. So you can go to the JupyterLab, search for JupyterLab, and you will get the installation option. Just go there and copy this command to install JupyterLab. So JupyterLab is installed. So if I run JupyterLab, it should start perfectly. So sorry, it's a typo. So now if I click on the link, it'll open the JupyterLab, and we need to select the kernel, and let's run this again. Run the TensorRT thing. Sorry, TensorFlow GPU commands, And also I want to see the version of the TensorFlow. So let's put this here and run this code. And you can see there is some, they have some warning, but it is working perfectly. So let's put print here because it is not showing anything. So let's print here and run this again, and you can see the device type is GPU and our TensorFlow version is 2.16.1. So our TensorFlow is working perfectly. Now if I want to save this, okay, sorry, so let's it's actually saved with the same name, so let's rename it, okay, and TF_GPU, I put the name for this notebook, okay, that's fine. Now let's close it and go to the terminal and close the Jupyter Lab. Press yes, and if you press ls, you can see that tf_gpu.ipynb file is here. Okay, so the server is connection lost. Okay, that's fine. Now I'm going to show you the bonus thing. We can install PyTorch here also. So let's go to PyTorch. And if you click get started, and here you need to select Linux, okay, and the stable version 2.3.1, and here you can see the CUDA 12.1 is supported by PyTorch. So we'll go with this, and just we need to run this command. It's pretty simple, not complicated like TensorFlow. So let's run it. And again, if you go below, so this is the important thing. We will run this, okay, to test the GPU. PyTorch is installed, so let's open Jupyter Lab. Here it is. So let's open the TF GPU, okay. So let's run the TensorFlow code again, and it's working perfectly. So let's run it. So you can see it's working. Now let's run the PyTorch one. So let's add print here, and let's check whether PyTorch is getting GPU or not. And it's true. So CUDA is available for PyTorch, and CUDA is also working for TensorFlow. So that's all for today's video. And actually, before making this video, I tested this code multiple times. I tested it with Ubuntu 24.04 as well as 22.04 WSL. So it works in both environments. So you can also use it with Ubuntu 22.04, no problem. So I try to make a comprehensive video for this because I had problems to install TensorFlow with GPU. So I researched on it and tested multiple times and finally get this way, which works perfectly. And I wanted to show you how to run those commands. Hopefully this will help you, and it will help you to, save your time also, time and effort. And it works perfectly. So hopefully you will like this video, and if you like this video, please like and also comment, and don't forget to subscribe to my channel. It's very important for this channel. Your support is very important, and it will help me to make more videos for this channel and grow the channel further. Thank you so much, and have a good day.